All right, so just a warm-up of going from logarithmic to exponential and then evaluating. So today, again, we're focusing on our natural logs, which we looked at earlier in the chapter, but today we're going to be solving equations that have natural logs in them. So remember that natural logs have a log base e, but instead of writing e, we represent that with just the natural log, ln. E is called Euler's number, so just like pi is irrational, 3.14159, etc. Euler's number is e, and it's located on our calculator in two places. There's one that has an e to the power button, and then there's also just the e button. So just the e button is your right above the division sign. So if you press second division, that'll get you your e, and if you type it in, you'll see what all the numbers are. And again, it actually goes on longer than that in our calculator. I press second in the division symbol. Now the one I prefer to use is second ln, because usually we're going to be raising e to a power, so it automatically puts the caret for you, so you don't have to type the caret too. So it's one less button that you can press. So if we wanted to raise e to the second power, you can do that. And then our natural log button is located right below the log. This again will be log base e. So anytime you see natural log, you'll use the natural log button. So we learned yesterday how to solve logarithmic and exponential equations because they were inverses. These are inverses of one another. The graph of y equals e to the x power and the natural log of x, which again, remember that this is really log base e of x. We just don't write it that way. So when we're solving logarithmic or exponential equations, we may need to use the natural log on both sides to solve. We also may need to use properties of logarithms to simplify and help us to solve. So, and remember, the inverse graphs always are reflected across the line y equals x. So you can see the two of them. But we're not going to focus on those graphs. We're just going to focus on solving today. So numbers 1 through 4 just ask us to rewrite each expression as a single natural logarithm. So we'll use our properties. First, we'll use our power property to take the outside number and put it back up as an exponent. So the natural log of 12 squared minus the natural log of 9. 12 squared is 144. And whenever we're subtracting, we can use the quotient property, which would be the natural log of 144 divided by 9. Oops. We'll get 60. Next one, do the same thing. Use your power property first, so 2 to the 5th, but it's 2 to the 5th. John? 32. And then we're subtracting. We can use the quotient property, which is division. So the natural log of 8. So if you guys can try examples 3 and 4, and then we'll take a look at solving. Remembering that the 1/4 power is the 4th root. Since they both have a 1/4, you actually could factor that out. You don't have to, you could do it to each of them. But it might be easier to simplify at the end if you do it this way. We know whenever we're adding logs, we multiply, so this would be 1/4 times the natural log of 3x. And then we can take our 1/4 power and put it back up there. Remembering that the 1/4 power is the 4th root, so this would be the natural log of the 4th root of 3x. It would be improper to leave it 3 to the 1/4 x to the 1/4. You should simplify those. Either put them in a parenthesis or change it to a radical. I think the directions will tell you to change it to radical form. All right, below we have solving. So solve the natural logarithmic equations by rewriting in exponential form, and we will check our answers by storing it in for x and checking. So remember that a natural log has the imaginary base of e. So we'll add that in. It's log base e. And we'll change to exponential. So this will be e to the 6th power is equal to 2x minus 4 cubed. Now remember, e to the 6th in our calculator is just a number. I wouldn't necessarily evaluate what it is right now because you're going to have to write out all those decimals then, so I'm just going to leave it e to the 6th. How would I solve for x? What's the first thing I have to do to both sides? Golden?
Distribute x
No. You cannot distribute since it's a binomial. You'd actually have to expand it like 2x minus 4, 2x minus 4, 2x minus 4, and then like FOIL, but I wouldn't suggest doing that. Jade? Take the cube root first. What is the cube root of e to the 6th? E to the what? Remember our exponents. Second, you'll divide those. E to the 2nd equals 2x minus 4. And then we should know how to solve from here, add 4 and divide by 2. But I would go ahead, again, leave this in exponential form so that you can type it all in your calculator at the end. So we'll add 4, and then we'll divide by 2. So I will get x equals e squared plus 4 divided by 2. Now I'll type that in my calculator and see what we get. So again, I'll press the second ln button to get e to the 2nd power plus 4 divided by 2. And let's just do, why did I choose 3 decimals? Let's do 4 like we did yesterday. So 5.6945. And then we can check this again by storing it in for x and rewriting in the original equation, which was natural log parentheses 2x minus 4 close parentheses caret 3. And we do not get my answer. What did I do wrong? Natural log 2x minus 4 caret 3. I'm getting 8 instead of 6. What we needed to do was just add in that extra set of parentheses before we checked it. Thank you very much, Austin. All right, the next one's going to be a little easier because we aren't going to have that parenthesis. We'll just put e to the 0.1 or the 1/10 power is equal to x. And so we'll type that into our calculator. E to the 0.1. And we'll do 1.1052. And again, we can check that, storing it in for x. This one we should not need parentheses because there's only one thing going on. So natural log of x equals 0.1. All right. Do you want to try the next two? Same type of problems? And insert your base e. And then we'll take a look at some of the exponentials whenever we get. Then our last type, which most students will find to be the hardest, these are exponential, like yesterday. So yesterday we saw like 5 to the x equals 10. And we would take the natural log of both sides. And then we take the x and put it out front. And then we divide by the log 5. Okay, the same thing is going to happen today, except we no longer have a number being raised to the x power. We will have Euler's number, which is our irrational number, being raised to that. So anytime you see the e, this is going to indicate to you that you have to, instead of taking the log of both sides, you should take the natural log of both sides. Now, before we can take the natural log, we do have to isolate the exponential. Okay, so step one, we're going to isolate our exponential. So we will start by subtracting 1.2 on both sides, and then dividing by 4. So anytime you have a lot of stuff going on, you need to isolate that exponential before you can take the logarithm of both sides. Now, technically you could still take the log of both sides, but it's just easier to take the natural log, and you'll see why in just 1 second. Give everyone a second to get caught up. All right, so now we are going to take the natural log of both sides. Some of you will forget to do it on both sides, so we'll do it on one and not the other. So just like we subtracted on both sides, make sure you take the log of both sides. Well, I'll just write that on a different line so we're not confused. The natural log of both sides. Then use your property of exponents. To move that 3x out front. So we now have 3x times the natural log of e equals the natural log of 3.2. Now, something that will help you is if you type in your calculator the natural log of e, it is just 1. So anytime you see the natural log of e, that's like log base e of e, which if you change the exponential will be e to the x equals e, so that therefore x is just 1. But the natural log of e is just 1. It will benefit you to change that. Otherwise, when you divide, you're going to have to use parentheses, and some of you will forget, and then you'll get the wrong answer. So it's just easier if you change that out to be 1. And then we'll say simplify. The natural log of e is 1. So now we just have 3x equals the natural log of 3.2. So we just have to divide by 3. And so we'll have the natural log of 3.2. Oops, close my parenthesis and divide by 3. So 0.3877. You can still check these. It doesn't tell us we have to, but it says you can. So let's do it. Store in for x. 4 second ln to get your e to the 3x power. Close that parenthesis and add 1.2. And we do get 14. So again, on a quiz or test, you can always check your work. Okay, the last one in this section, we do have a binomial exponent, which means you're going to want to group that. Put it in parentheses so that you don't mess up when you move stuff around. Now this one, we don't have to isolate the exponential. It is isolated. So we can go straight to step 2. We're going to take the natural log of both sides. Use our properties of exponents. Power property to move that out front. Now, if you forget that the natural log of e is 1, you could like divide by the natural log of e and then subtract 1. It will work, but it's just a lot easier to get rid of that because that's just 1. So then we just have to undo addition with subtraction. So natural log of 30, make sure you close that parenthesis and subtract 1. 2.4012. Of course, we could check that, but I'm not going to take the time to. All right, the last one is a word problem, and this is a formula that we actually do in advanced algebra with trig. but you guys will see this formula in pre-calc next year. You'll do a bunch of exponential word problems, which deal a lot with banking. So whenever you put your money in a savings account, the interest will be compounded daily, monthly, or continuously. And there's different formulas for how your money and the interest is calculated. The first one is, they call it the PERT formula because P-E-R-T. So they call it the PERT formula. Let's first talk about what everything stands for, and they tell you this if you read through the problem. A is the future value of your money. So how much money will be in your bank account after a set amount of time, which will be what you had in there, and then also the interest added on. P is your initial value or deposit that you put in. E, of course, is Euler's number. That's our 2.7, etc. R will be your interest rate as a decimal. So just a reminder, 4.25% is what as a decimal? Some of you screwed this up on your assessment. Jade? 0.0425. You move the decimal 2 spaces to the left. If it were 0.4%, what would that be as a decimal? Ashley? 0.004%, or as a decimal. So just make sure that you just convert those. And then T is going to be your time in years. And we're going to just plug into the formula. So it says an initial investment of $200 was made. So initial, that's your P, or your, we call it principal and advanced algebra trick, but it's your initial value. It is worth $315.24. That's your future value. That's your A. After 7 years, that's your T, and is compounding continuously. Find R, the interest rate. So 315 goes in for A, 0.24, equals 200 times E to the R7 power, or 7R power. You're going to solve this just like we did above. First step was to isolate our exponential. So we need to isolate the e to the whatever power. So I'll divide both sides by 200. Did I have to round that? No, but write out all those decimal points. Okay. If it were like going on forever, you'd have to write them all out. Equals e to the, I'm going to call this 7r power, just so it looks prettier. How do I solve this exponential? What do I have to do to both sides? Find out what r is. Caleb? Take the log of both sides. Again, I would use the natural log since we see e. So this will be natural log and natural log. Use your properties of exponents to take that 7r and move it out front. So we'll have the natural log of 1.5762 equals 7r times the natural log of e. Natural log of e, we've already discovered, is just 1. So we just have to divide both sides by 7. So we'll take the natural log, 1.5762, close my parentheses, and divide by 7. 0.065. Now, since this is as a decimal, you'll have to change it back to a percent. So you'll move the decimal 2 spaces to the right this time. So we'll get that it is 6.5%. So you can try the closure, which asks you to find the number of years. So you would be finding T. This time they give you A and P and R, and they ask you to find out what T is. So your answer for this one will be in years.
Staff team will now meet in room 164, or 124, I'm sorry, room 124.